Hi, my name is Jeff Eberhard, and I'm here from the Oracle Cloud VMware Solutions team to help you learn a little bit more about our offering. Over the next 45 minutes, members of the solution architecture team are going to be going through deep dives on different architectures and demonstrations, including Oracle Cloud Infrastructure and OCVS basics, migrating and replatforming your applications using OCVS, establishing an advanced hybrid cloud, virtual desktop infrastructure, and even a session on business continuity and disaster recovery using Oracle Cloud VMware Solution and your preferred DR solution. We know there's no way that you're going to get everything you want to learn out of an 8-minute session on each of these topics, so the team has developed deep dive architectures and demonstrations that you'll be able to access after this session if you want to learn more. To get started, I'd like to introduce Priya Yadlapalli, a senior solution architect on the team, to talk to you about Oracle Cloud Infrastructure and OCVS basics. Priya, take it away.
Thank you. Thank you all for joining us today on this deep dive session. My name is Priya Yadlapalli. I'm a senior solution architect on the Oracle Cloud VMware Solution team here at North America Cloud at Oracle. I'm going to spend a few minutes today talking about the journey of this partnership with VMware, and then move over to the basics of OCI and what to consider when addressing OCI for the first time with the perspective of OCVS. So to begin, I'd like to share this interesting graphic created by my colleague. This conveys company as a service. The journey of Oracle and VMware's partnership is founded in solving performance and security concerns. Oracle's journey was initially rooted in providing the most secure and performant database, and then we saw this evolve into the initial and ultimate journey of SaaS. At that time, we lacked the capability to deliver on enterprise robustness. So this is where ancillary functions enter to create that performance SaaS for all. Think about database management outside of your SaaS system, doing more with less resources, and clear functionality and best practices without the overhead and management planning. Some of our customers' needs were not met by our SaaS offerings. This led to the building of greenfield applications utilizing microservices and, of course, Kubernetes to allow for the customizations on an enterprise management platform. When considering packaged applications and legacy applications, the dependencies are synonymous with that of VMware. VMware has decades of experience delivering on the promise of support, compatibility, and capability. Our partnership's main premise is to support all of the applications which our enterprises have relied on for decades. Oracle will support and work with customers to build integrations with partners and to provide that robust platform to run your business. Now I want to move over to review some of the key components of what to consider when preparing your tenancy for OCVS. So to begin, you'll need the necessary identity and access management policy granted by a tenancy administrator. With OCVS being completely customer managed, it's important to not only consider secure VMware identity policies, but also OCI policies. This is an important tool when planning for security and access within your tenancy and team. Then the next step is to create a virtual cloud network with an IP CIDR range of the minimum required size or larger to run the SCDC, software-defined data center, that's needed. We recommend that you set up the connectivity between your VCN and your on-premise environment before starting the provisioning process for your SCDC. The diagram I have on this slide shows how the various components of the OCVS SCDC are deployed on Oracle Cloud Infrastructure bare metal compute instances, and how the solution is integrated with the larger OCI environment. This specific diagram shows 3 ESXi hosts within the SCDC, which reside on the OCI virtual cloud network. This is the minimum configuration for our offering, and this can scale up to 64 nodes per cluster. The center host shows the installed VMware software components for compute, network, and storage. The NSX overlay manages the flow of traffic between the VMs and between the VMs and the rest of the resources in our solution. The VCN here includes various gateways which allow the connectivity between the SCDC and the on-premise network, the internet, and then again, the larger Oracle Services network. When you provision an SCDC, you have the option to enable HCX Manager. This is not shown in this diagram. However, HCX is an application mobility platform. This simplifies application migration, workload rebalancing, and the business continuity across data centers and cloud. For HCX to function properly in your VMware solution, you must have 2 things. A fast connect for inter-site communication. This provides you that dedicated private connection, as well as a NAT gateway as required by HCX Manager for license activation, updates, and that VMware enhanced support. So now I'm going to take you over to the OCI console to walk you through how to navigate throughout the console and access some of the resources I talked about. When you log into your Oracle Cloud Infrastructure tenancy, this is going to be the home dashboard that you view. There's two things I'd like to point out on this page. The first being the profile icon in the top right corner. This is where you can confirm that you are in the correct user as well as tenancy. Secondly is going to be the region dropdown. This is always going to default to your home region in which you subscribe to during your tenancy activation process. However, this is also where you'll be able to toggle between other regions in order to access resources within those regions. Secondly, let's go move over to the hamburger menu. We're going to scroll all the way down to the bottom, and we're going to look at the governance and administration section, specifically identity. So users, groups, policies, compartments. These are some of the critical resources I mentioned earlier, which will help you assess and manage security and access of your tenancy as well as your team. This is also a great way to logically organize your cloud resources. Next, we're going to move up to the networking section and click into virtual cloud networks. While my focus today isn't to show you how to create a VCN or to create some of these resources, it is there to focus on how to navigate and access these resources. I'm going to be confirming two things on this page. One is that I'm working in the correct region. Secondly is that I'm working in the correct compartment. You'll see here we have an active and available VCN to work with, and this is going to be the VCN that we provision our SCDC within. Let's go over to the VMware solution now. We're going to go back to the hamburger menu. We're going to go to the solution section, and we're going to click into VMware solution. Again, I'm going to confirm two things, the same two things, which is that we're working in the correct region as well as the correct compartment. You'll see that we have our active SCDC ready to go and provisioned here. Let's click into it. So on this page, this is where you're going to be able to view all of the details of your SCDC. You'll also be able to see all of the details in which you designated during the SCDC creation process. You'll see a number of VMware client links here, as well as the user credentials on the right side. One way to access these clients is to create a bastion host, a jump host, and use this link as well as these credentials to log in. If we scroll down, this is where you're going to see our ESXi hosts. We have 3 down here. So it took about 2.5 hours to provision this SCDC, and it'll take approximately 30 minutes to add and create an additional ESXi host. If we go over to the right, you'll also be able to view some other actions that you have the ability to take within the console directly. Thank you all for your time today. I hope you enjoyed this demo.
Hi everyone, my name is Richard, and in this section, I'd like to show you on how the Oracle Cloud VMware Service integrates with the overall Oracle Cloud and how it can interact with all of the native services. So here you see on my screen that I am logged into the Oracle Cloud, and I have already a Oracle Cloud VMware Service provisioned. So I can go to this service here, and you'll find all the details about the service, about Virtual Center, and that kind of stuff. But at the bottom, you also actually see the 3 physical bare metal servers that I have. And I can directly log into those servers as well. As I said, with Oracle Cloud VMware Solution, we say that you have full administrative privileges across the entire VMware stack. So I can copy the password, and if I go to the Compute Cloud service, here on the left menu, you will see here the same 3 bare metal servers. So I can click on one of those servers, and you'll see I have the IP address here. So if I can go to this IP address, you'll see I get the traditional ESXi MUI that I can now log into. And here, I can see the bare metal server, the Oracle server, the 52 cores, and I can do whatever I want. The same thing for if I really want to have console access. So I can SSH into this server as well. Now, when you create an OCVS service, you have to provide SSH keys, and I can reuse these keys to directly log into this server. So I can go to my 10.100.0.2, and you'll see that I have here a full normal ESXi server that I have full root level access into. Now, even if things go completely crazy on you and that your server is not accessible over the network for whatever reason, in the Oracle Cloud VMware Solution as well, or in the Oracle Cloud in general, you can go to your compute instance, and we have here the option from a console connection session. And this really allows me to get full direct console access to this server, so even if it doesn't have any form of network connectivity. Now, besides connecting to the ESXi and the VMware components, of course, it's also important that the workloads that you run on top of the Oracle Cloud VMware service can directly communicate and work with any of the Oracle Cloud native services. So let me demonstrate you on how those kind of things can be done. The Oracle Cloud VMware service sits in your own tenancy. It sits in your own what we call virtual cloud networks. And if I go to my VMware environment here, let me log into Virtual Center. You'll see here I have my my environment, I have my 3 bare metal servers, and I actually have here my own resource pool with a virtual machine in it. And if I want this virtual machine, for instance, to work with a native OCI cloud service, we can very easily set that up. So if I go into the Oracle Cloud, in the menu, besides the Oracle Cloud VMware service, you'll find many other services, analytics cloud services, data science cloud services, but also a whole bunch of database cloud services. I can have an autonomous database, I can have a JSON database, a MySQL database, all kinds of database options. In my case, I'm going to the bare metal VM and Exadata cloud service. And if you, for instance, need a database in the Oracle Cloud, you just can click on the Create Database System option. And here I can create, using a very simple wizard, an Oracle database as a virtual machine, or as a bare metal server, or as an Exadata. And I can decide on how big it should be, etc., etc. Now, I already have done that. I already have an Oracle database running. And in this case here, I have actually 2 databases, 2 systems running. It's a rack clustered environment, a 2-node cluster environment with an Oracle database. And I have here the IP address of that cluster, 10.120.99. Now, if I right now would go to my virtual machine that sits on the top of the Oracle Cloud VMware service, this Richard desktop, and I'll launch a console session here. If I right now would try to ping that database, 10.120.99, you'll see that this virtual machine doesn't have any connectivity to it. This virtual machine here is actually running on a network called RichardNet, which is an NSXT network segment. It's the overlay network on top of VMware. And by default, it cannot connect to anything of the native Oracle Cloud services. So to enable that, I can go to the Oracle Cloud VMware service again. So I'll go in my console here to the Oracle Cloud VMware service. I'll go to my deployed SDDC. And on the top here, you'll find 4 wizards. And these wizards allow you to very easily set up the connectivity between the VMs that you're running on top of NSXT, on top of VMware, with, for instance, on-premise networks through Fast Connect or VPN tunnel, but also to your own resources in the Oracle Cloud that are connected to a virtual cloud network. So I'm going to pick that particular option. And here I will specify what the IP range is of the NSXT segment. So in my case, 102.1.0/24. This is the IP address of my virtual machine. So that's the IP range within the NSXT network segment. Then I want to connect that to my database. And my database sits in a subnet native in OCI called Subnet Native Services. That's where my database has been deployed into. So I'll select that particular subnet. And what you will see is it will automatically go create the right network security group, the right routing tables, the right security list for these kind of environments, these 2 environments to be connected up to each other. So I'll click on Apply Configuration. The wizard does a few steps. And now instantly I can go back to my virtual machine. And if I now try to ping my Oracle database, you can see I have direct connectivity to it. So this is how easy it is to set up connectivity between native services and services VMs that you're running on top of the Oracle Cloud VMware solution. Now, besides allowing my VMware virtual machines connect to my native Oracle Cloud services, I can also do it the other way around. So in my case here, for instance, I also have 2 web servers deployed within my environment. And they're sitting on the same NSXT network segment, RichardNet. And I want to expose these web servers to the outside world. So one thing I can do is I can go to the Oracle Cloud and I can go to the network settings. And here I have, for instance, a native load balancing service. And you can create these automatically, very easy to do. And in my case, I already have a load balancer created. And all I need to do is actually go to this load balancer that I've already created, go to its backend set, and add my VMware virtual machines in there, because the Oracle Cloud VMware Solution is part of my normal environment. The routing has been set up, so I can very easily control this now. So if I go to my backend sets, I'll add the IP addresses of my virtual machines. So that is this 10.102.1.44 and 10.102.126. So I'll do a 10.102.1.26 and a 10.102.1.144. I'll add that into the load balancer. And now these virtual machines are part of the public cloud load balancer. If I now go to the public IP address of this load balancer server, so this is the public IP address of my load balancer. Here we go. You will now see that I get a web page from my virtual machine that's sitting on top of the Oracle Cloud VMware Solution. Now this is load balanced between the two VMs, so if I refresh, you see here that the IP address is continuously changing between those two virtual machines. So that's how I can very easily use an Oracle Cloud native service, like a load balancer service, that I can put in front of my services that I'm running on top of the Oracle Cloud VMware Solution. So this is a demonstration on how the Oracle Cloud VMware Solution can integrate and can be managed from within the Oracle Cloud itself, and how you can leverage both the best of running your own virtual machines on top of VMware, on top of the Oracle Cloud, and using native services within the Oracle Cloud.
Hi, my name is Justin Hakimi. I'm a principal cloud architect at Oracle in our Oracle Cloud VMware Solution business unit. What I'm going to demonstrate today is a high-level architecture that we're working on with VMware to validate Horizon on top of Oracle Cloud VMware Solution. The reason we're validating this architecture is because companies are continuing to need to adjust to this post-COVID world, where working remote has become the standard. A key takeaway with Oracle Cloud VMware Solution is that it's a day one offering within each of the existing 29 regions today, and it will be offered in any new region as they become available. Lastly, Oracle Cloud VMware Solution is the first to achieve FedRAMP High certification. So being able to provide your virtual desktops via Horizon inside of Oracle Cloud VMware Solution has become a very easy way of consumption and providing these desktops to your users. I'm going to jump through 3 scenarios, basically showing a high-level architecture, off-net traffic flow, and on-net traffic flow. So this diagram here represents the core components of Oracle Cloud Infrastructure, Oracle Cloud VMware Solution, and Horizon virtual machines installed inside of your SDDC within Oracle Cloud VMware Solution. Now we're going to talk about the traffic flow for off-net users that are accessing their Horizon environment. So these users are able to access a connection server and get a desktop through the internet. So as they traverse the internet, they get pushed to a public load balancer. The public load balancer pushes it through into the DMZ to your unified access gateways. This then authenticates the user, pushes it back through into the private subnet load balancer, and issues a desktop. Now, going with the on-net traffic flow is we're able to bypass the UAGs, and the end user, which is accessing the environment either through a fast connect or a VPN tunnel, can get authenticated and then directly pushed to their virtual desktop. Makes it very easy to consume and set up. Now I'm going to talk to you about hybrid cloud extension and what it means when you utilize it with Oracle Cloud VMware Solution. I'll then transition into an interactive demo as well. So what we're hearing in the field today from our customers are challenges around migrating to the cloud. They ask questions like, how can they move their workloads without changing what they do today from a standard operating procedure? Sometimes they don't have a large window for migration. Do they have to buy extra software and services and tooling? How much risk will there be because we can't tolerate significant downtime? And do I need to hire more staff or send them to special training? The great thing is HCX will address these concerns. So a few of the features about HCX, which stands for Hybrid Cloud Extension, is it leverages any vSphere to vSphere migration. So if you're coming from an older legacy version of vSphere, you're able to lift your workloads into the latest and greatest that VMware has to offer from vSphere. WAN optimization is also included so that you can move more data with less bandwidth. You also have the ability of extending your network via layer 2 extension, so you don't have to re-IP your workloads. Then we have several migration options. The first of which is bulk migration. This is an offline migration where you can schedule multiple workloads to be migrated from your on-prem into your cloud target seamlessly. The next one is a live migration. You may know this as vMotion. vMotion allows you to move your workloads live without losing any data or downtime. The last piece that I'd like to talk about is disaster recovery. So HCX does allow a simple way to protect your VM workloads. Now, we're going to cover SRM in a later session, and that's full orchestration of your disaster recovery. This slide here, before I jump into the demo, is just stating how easy HCX really is to implement on Oracle Cloud VMware Solution. We call it the Migration Easy button. When you create your SDDC, there's a checkbox to enable HCX. It gets automatically deployed. Then from there, you install another HCX appliance in your local data center, and then you configure connectivity. Now I'm going to jump into a demo and demonstrate bulk migration, vMotion migration, and DR. Now transitioning into the demo, we're going into your vCenter where you can access the HCX console. Once we select HCX, we have a dashboard that will give us an overview of our environment as well as if any migrations have happened. The first thing we're going to do is demonstrate a bulk migration. We can simply click migrate, select the virtual machines that we want to migrate. In this case, I have two demonstration bulk 01 and bulk 02 VMs that we will use. We'll go ahead and click add. And then we'll go through some options about where these VMs will live from a compute and storage perspective. We'll select a workload resource pool. And we'll select the folder. Storage is vSAN because that is the storage that is used inside of the SDDC. Now we have the choice of picking a vMotion, a live migration, or a bulk migration, which is offline. We'll go ahead and select bulk. And now we have the ability of scheduling this. For the sake of this demo, we want it to happen immediately. So we're going to go ahead and check the box here, click apply. Now we need to expand each one of these VMs and make sure we select the destination network. We're going ahead and selecting a matching network at our target. We have to do that for each workload that we're going to migrate. Sometimes these workloads may have different networks, but for our case, we're going to keep it as simple as possible for this demonstration. Lastly, since these don't have VMware tools installed, we need to select force power off. Otherwise, our validation will fail. Great, validation is successful. We can now proceed with the migration. Just to let you know, we're going from our source, which is a data center in Toronto, and we're migrating to our cloud data center in San Jose. I'm going to head and click go, and it will start the process, which can be tracked here in this dashboard. Now we're going to go ahead and start a live migration. So we'll go ahead and click migrate again. We'll go through the same options that we just reviewed about placement. And we'll select the vMotion demo machine. Go ahead and add it. Go through and set the same options as before for the demo. But this time in the migration profile, we're going to pick vMotion. We're also going to make sure we start it as soon as possible, although we could schedule it. But for the sake of the demo, we're going to make it immediate as well. Now, the last step, again, is to add the destination network. Go ahead and select that. And now we're going to validate. Validation successful, we can proceed with the migration. We'll go ahead and click go, and it will start the process. You can see the task started here. Now, the last part of the demo, while everything else is running, is showing you how to protect a VM by utilizing HCX's disaster recovery option. It's as simple as coming here, selecting protect VMs, selecting the VM. In our case, we're going to use the HCX DR demo VM I created. We do have some options such as activate compression, activate quiescence, as well as setting those same options around where it lands from a storage perspective and the resource pool and or folders or hosts. Now, what differs from a DR perspective is you do need to set an RPO, which is as tight as 5 minutes because this uses vSphere replication. We also need to pick snapshots from a protection perspective. We'll go ahead and set it to 1 hour. And we'll set it to 1 snapshot. This can be adjusted based on your protection needs. Then we go ahead and we click finish. And it kicks off the DR workflow. So it's essentially replicating the data over, and once it's satisfied, then it's sending the delta over every 5 minutes. So once these tasks are completed, they will show up as successful, and you'll be able to check them in this dashboard. This is our vMotion and our two bulk VMs that are basically being synced over and migrated. From a disaster recovery perspective, we can now see also that we're protecting this particular VM, and it's preparing it on your target side. Now, this will take time, and we're going to allow time to elapse, and then we'll fast forward once it's completed. I hope this session was very useful to you. Thank you, and enjoy the rest of the content.
Welcome to the Oracle Cloud VMware Solution Business Continuity Disaster Recovery Demo. This video will demonstrate how to protect your OCVS workloads using Site Recovery Manager and how to show a successful DR test. So for this specific demo, we're going to be using SRM as the DR solution, but other products such as Veeam, Zerto, and Commvault have already been tested, validated, and supported to operate within OCVS. With full root access to the ESXi host within OCVS as a self-managed solution, you can pretty much use any DR solution as you please. You have access to install any VIBs onto those hosts. So SRM is used to help protect workloads by utilizing replication across multiple sites and leveraging orchestration for a successful power-up at the target site. So as we log in here to the vCenter console, we have two sites, Site A, Site B. Site A being Montreal, which is our source, and Toronto side, which is hosting our disaster recovery side, labeled as target. And let's look at our workloads. There's just 3 small VMs for this demonstration. So the production is only consisting of 3 VMs being replicated over here, indicated by this workload folder. And you can see with those little dots indicating that these VMs are being replicated. So let's go into Site Recovery Console and show how these VMs are being replicated. So we go over here into Replications. We indicate the 3 VMs here. And as you can see, the target site being Toronto. And I've already pre-synchronized these VMs so to save time for this demo. We go over here to protection groups. So the protection groups pretty much just groups the VMs either by crit level, app dependency, or any technical or business requirements. Just group VMs together. As we go over into the recovery plans, this is where the orchestration occurs of how the VMs will spin up and power up onto the target site. And one thing I want to indicate here, if you're utilizing multiple OCI regions, maybe multiple services across regions, this is where we can go to do any repointing of any IPs or any resources or services within OCI. So it makes it really easy to maintain that connectivity to those resources. So you just enter your script in here, any locations where the script is, and it's simple as that. As we go in here, there's two scenarios we can do: a test or a run. A full run will do a complete failover of those VMs, of those replicated VMs will spin up online on the target site in Toronto. So for these 2 options within run, you can either do a planned migration or a disaster recovery. But for this simple test, we're just gonna do the test. So this will take those 3 VMs and spin it up within an isolated network. There will be no outbound connectivity, but we will be able to test interconnectivity within those VMs. So we'll just kick off this test. And as you can see here, the priority VMs, you can set the priority level of those VMs within the protection group. So say you want the database server to spin up before the application, before the web server. It's all customizable here. So as we see the replication or the spin up of those VMs has been completed. Let's look over here on the Toronto side, or DR site. As we can see, indicated by the green triangles, that those VMs are successfully powered up. And let's take a look at the IPs of the VMs. So we can also retain the same IPs. So no need to re-IP on the target side. But we'll do a simple test that even though they have the same IPs, there's no IP conflicts, and the test VMs will have 0 outbound connectivity. So we go in here. Let's go into the Toronto side. This is on our Toronto jump host. And we'll just do a simple ping test for this. And just showing here, we can't even get out to the gateway. Showing 0 connectivity. It's very important to have no connectivity out in our test network. And we're just going to ping VM02 in the other workstation, or the other server, VM03. And another test we're going to do is to make sure that we can't even ping the vCenter where this is being hosted. So now that the test seems successful, even though we're just using a simple ping test, we can proceed to clean up the test environment. What this will do is roll back any changes that may have been made to those replicated powered on VMs. So we'll just roll it back to its original state before power up. This kicks off the cleanup of the test VMs. So this rolls back any changes that may have been made to those replicated VMs, those powered up VMs. So let's go back over here and indicating that those test VMs have been powered down and that the production workload is still online untouched. So we can provide that test while the production is up and running. So I hope you find this demo useful in displaying that OCVS can be consumed the same way that you consume your current managed VMware infrastructure. There's no strict guidelines that most public cloud providers have. You have full direct root access to the ESXi hosts to install whatever you need to install to help support your DR needs and solutions. So thanks for joining me in this demo today. I appreciate it.
Wow, those were some fast-paced but interesting technical overviews, weren't they? As I mentioned at the beginning of this session, these same wonderful presenters have put together deeper dives that are available now. Please go to oracle.com/VMware or our virtual resource center to view any of them at your pleasure. Thank you again so much for joining us today, and we can't wait to work with you soon.